The recording of the webinar will be uploaded to the Google Classroom. Please rename yourself using the registration number provided in the handbook and your name if you haven't done so already. Today, we are honored to have a distinguished academic with us who will guide you through the predictive maintenance using IoT and big data analytics for EV. Thank you, sir, for accepting our invitation and joining us today to deliver the keynote speech. Dr. Sudheera Navaratne is a senior lecturer at the Faculty of Engineering, University of Peradeniya. He received his BSc in Electrical and Electronic Engineering from University of Peradeniya in 2007 and pursued his MSc and PhD in Electrical and Computer Engineering Technology at Purdue University, USA, specializing in smart grids and advanced metering infrastructure security. His research focuses on smart grids, microgrids, distributed energy resources, and the application of AI and multi-agent systems in power systems. Dr. Navaratne has held leadership roles in IEEE, including Chair of the PIS Sri Lanka chapter, and has been involved in research projects on renewable energy integration and power quality. So, ladies and gentlemen, please welcome Dr. Sudheera Navaratne to deliver the keynote speech on predictive maintenance using IoT and big data analytics for EVs. The spotlight is yours.
Thank you, Patum. Thank you for the nice introduction. I believe you can see the shared screen.
Yes, sir, we can see.
Okay. Yeah. So you have seen me, so I'm not going to turn on the video because sometimes that might affect the quality of the delivery due to the connection issues. Thank you for giving me this opportunity to share the knowledge on this predictive maintenance for electric vehicles and the corresponding infrastructure. The predictive maintenance is I don't know, like I can't say it's a relatively new thing, but it is applicable in many areas, not just for the electrical vehicles, but for many applications. The predictive maintenance is used to enhance the quality, reliability of that particular applications. Since now the electrical vehicles and associated infrastructure is picking up the market, the predictive maintenance for electric vehicles is I can say it is a kind of a relatively new area, and a lot of research is also happening in this area, as well as a lot of practical applications are also there. And the enhancing the development in Internet of Things and the big data analysis and the machine learning will greatly help this predictive maintenance to pick up and perform its best. Okay, so today we will kind of look at how we can use the predictive maintenance for electrical vehicles. In order to enhance the reliability, the comfortability, and the user experience, as well as the safety in the first place. Okay? Right. So saying so, actually, I'm not going to go into very deep into the theoretical parts here, but I will just give you the brief introduction how these different areas like IoT, big data, and the machine learning, and so on will help you to achieve the goals of predictive maintenance in electric vehicles. Okay? And we will also discuss about some actual applications. Okay? Right. So, and then, I will leave you to, if you would like to continue on this area using machine learning and IoT, I will leave you to work on that. Right. Okay, so let's start our discussion. So this is kind of I believe this talk is more toward the end of this workshop series. So you might have heard a lot of things about the electrical vehicles and their infrastructure, associated infrastructure, and so on. So you might have seen this slide or something very similar to this, number of times by now. So I just want to give you the information that the electrical vehicle market is picking up in the world very rapidly. You can see starting from 2015 to 2023, there is a exponential growth in electric vehicle market. And in the right hand side, you have the logos of the pioneers in this market. There are a lot of companies that are the manufacturing electrical vehicles. So you can see that by 2023, it's like 40 million, right? The electric vehicles they are in the world, right? And it is picking up and it is increasing rapidly. And as you already know by now, many countries, many governments are encouraging the use of electric vehicles in order to, support the environment, right? So as you know, the electrical vehicles will reduce the emissions to the environment. So many countries are now talking about achieving the carbon neutrality, right? Many countries, including Sri Lanka, has promised to achieve the carbon neutrality by 2050. And some countries like China, they have set their target to 2060 because they are in the growing industry, and they expected to reach the carbon peak by 2050, and then they are trying to achieve the carbon neutrality by 2060. But anyway, so by 2060 or a little beyond that, many of the countries in the world will achieve the carbon neutrality. So one step to reduce the carbon emission and achieving the goal towards the carbon neutrality is replacing the internal combustion engine based vehicles by the electrical vehicles. So you can see it is the major factor is the environmental impact. So it reduces the carbon emission, and then it's improve the air quality, and it will be a sustainable solution for the transportation industry, right? So that's why people are going towards the electrical vehicles, replacing the internal combustion engine type vehicle. Okay. Saying so, I don't know whether you have seen a slide like this. Many EV workshops doesn't show this part of the story, right? So they talk about the sustainability, environment friendliness, and so on. But there are safety issues associated with the electric vehicles, right? So this is basically focusing on the issues caused by the battery system, but there can be other issues as well. So you can see because of the battery systems, getting heated up. You can see here. Right. So here you can see a single cell heated up, and then that heat is transferred to the other cells of the battery. So when you look at the battery pack level, initially there is no much impact seen. So you will get a warning, and then eventually that will spread to the other parts of the battery pack. and so you can get the smoke and things like that. So you have to escape the car, and then eventually it can catch the fire, right? And sometimes even after 1 to 3 hours after you extinguish the fire out, the internal heat of the battery can still be there in the battery pack, and it can reignite the battery pack in the vehicle. So I'm not saying that the internal combustion engines doesn't cause any fire, but yeah, it can. If it heats too much, it can cause fire as well, right? But in the electric vehicles also, you have these safety issues. So whoever manufacturing these the vehicles has to make sure that these safety hazards are minimized or make zero as much as possible, right? So that is very important, right? So in order to do that, so you need the regular maintenance, right? So I think most of you have experience with the internal combustion engine type vehicles, or the normal diesel or petrol vehicles. And so you do the regular maintenance, right? You check your engine, and you change the oil, and you change the filters and everything. So is a regular maintenance that everybody do in their vehicle, right? So the same thing will apply to the electrical vehicle as well, right? But if you look at the maintenance cost associated with the internal combustion engine type vehicles with the battery electric vehicles, so here you have the hybrid electric vehicles and plug-in hybrid electrical vehicles. So you can see the maintenance cost is low in the electric vehicles, especially the battery electric vehicles. So you can see for a maintenance cost per mile, so it is $0.10 per mile, right? For the internal combustion engine type vehicles, and for the battery electric vehicles, it is less as $0.06 dollars per mile. And the various the maintenance services or the maintenance associated with the different types of engines are the listed in here. So I'm not going to go into the detail here, but you can easily relate them by using the color. So for an example, in the EV here you have the EV battery coolant, right? Engine coolant and things like that, and so on. And you don't have these the fuel filters and so on, right? In here. So the maintenance cost is less in the electrical vehicles compared to the internal combustion engine type vehicles, right? So if you look at the global electrical vehicle maintenance market, so you can see for the EVs, the global electricity vehicle market is the maintenance market is also increasing because now as I said, the electrical vehicle is I would say the relatively new to the market, especially in countries like Sri Lanka. And then, because of that, this maintenance market also needs to pick up, and the new technologies, whoever do the maintenance has to learn these new technologies and how to do the maintenance and repairs and so on, right? So, so you can see the compound annual growth rate of the electrical vehicle market in US in this case is about 12.2%. So just for your information, I have put small information here how to calculate this compound annual growth rate, right? So it is the beginning value, the final value divided by beginning value times the 1/, times in year. So you can calculate starting from any time to any time, right? And -1, okay? So that's some theoretical part you don't have to worry about. But just for your information, if somebody is interested, I have put it in here. Okay. Right. So now saying so, so you know that in many scenarios, so whatever the car you have, right, uh, you do the maintenance, right? So it has to be done to in order to prevent certain damages or certain failure. So that is called the preventive maintenance. So the most of the things that you do to your car is the preventive maintenance, right? So you take a series of tasks in a sequence of time. And for example, if you get the internal combustion engine type vehicle, you change the fuel, and you change the oil, and you repair the engine, and you remove the oil filters, and then things like that. So you do it regularly, like every I don't know, like every 10,000 miles or something like that. So you do it, right? So that is a preventive maintenance, right? So this is, when you go for this, the maintenance, sometimes you scan your car and you get the scan report. So you get some information. So you may detect the possible failures in advance in the preventive maintenance. Okay. But the tasks are taken to prevent any failures in the future. So basic idea is to mitigate the future failures in preventive maintenance, right? So examples are changing the oil, lubrication, battery replacements, and etc. Right? But in a typically, what you do is you run the car, and if something goes wrong, you repair, and it becomes okay, and then you run for a while, and again problems come, maybe the same problem or maybe another problem due to or associated with that problem. You never know, right? So it goes like this, right? But when you come to the preventive maintenance, so you run okay, and in a certain level, where you think that the car is good enough and not yet broken, right? You do the some maintenance, right? So it comes back to the okay stage, and it goes like that. And over the aging of the car, uh, you know uh, after certain time period, if you have experience, that cars are starting to give a lot of trouble, than the comfort, right? So that's how the preventive maintenance will uh, you know uh, keep the condition of the your vehicle, right? And in the predictive maintenance, you go step beyond, right? uh, and then in this case, unlike the preventive maintenance, so in the preventive maintenance, when you want to inspect the car, you have to go to the technician, and you have to show him and do the scan, by using that port, and you get the car health information, and you may detect the possible failures, but it is done in regular intervals, right? But if you go to the predictive maintenance, the inspection is carried out using the technological tools, such as the Internet of Things, and the big data analysis, or the machine learnings and things like that. Right? So this inspection is now carried out regularly or more frequently, or if possible continuously, right? Uh, uh, and so because of that, it is easy to detect the possible failures in well advance, right? So you can detect the trends, and whether the car is going toward a certain failure or not, it can be detected very easily, right? So as I said, it uses the advanced technologies, such as the artificial intelligence, to detect these failures, right? And then you can also take associated with the predictive maintenance, you can take the optimal action to avoid any failure. Right? So that's the difference between the preventive maintenance and predictive maintenance. So in sometimes when you go for the preventive maintenance, you spend a considerable amount of money, and sometimes uh, just believing that if you don't do this maintenance, that might cause a failure in a near future. But in actual scenario, that may not be the case, right? Sometimes people say like come after I can't remember the exact value, like 5,000 miles or so to next inspection, right? But it sometimes you may run 10,000 miles or longer without any inspection, right? But people still believe that if you don't do the regular, checkup, your car will fail very, very badly. Right? But in the predictive maintenance, you don't have to, spend a lot of money doing the unnecessary maintenance. Right? So it will detect the possible failures automatically, and it will inform you, so you can what to spend, and how to get your car back into the good health. Right? So that's the advantage in the predictive maintenance. Okay. Right. So okay, so let's look at the predictive maintenance a bit details. Okay. So this is a data driven approach, right? So everything is depends on the data, right? So that's why the big data and machine learnings are the very, very popular tools in the predictive maintenance. So you need to have a good chunk of data, right? Connected from or the collected from the sensors, right? In order to predict the maintenance needs, right? And you can utilize these data to detect any anomalies, right, in the car. So you can identify the patterns and abnormal behaviors of the sensor information, right, and so on. So this anomaly detection is one of the major components in the predictive maintenance. So we will look at this that in detail later, right? Sorry. Right. So you collect the bunch of data, and by using this data and by using the advanced technologies like AI, you detect the anomalies, right? So by detecting the anomalies, you can predict the maintenance requirement, right? So then you can suggest the optimal solutions to overcome any issues in the vehicle, so which will increase the efficiency of the vehicle. Basically, it's reduce the downtime of the vehicle, right? And also it reduce the operational cost in electrical vehicle as well. So exactly or what is the fault, and what you should be done, and so you can spend money just for that, right? And you do it regularly, you will keep your car in a good health, right? So in order to do that, you need the real-time monitoring, right? So you do the continuous monitoring, as I said, the vehicle health, and ensure timely interventions before failure occur, right? So you exactly address the failures, possible failures, and if you do that, you can run the vehicle smoothly, right? And it also eventually enhance the safety, right? So by addressing the potential failures well in advance, make sure uh, the safety of the vehicle is improved, right? No sudden brake failures, no sudden fire in the battery systems and things like that. So it will greatly enhance the safety, which is the very the important and the must address part in the electrical vehicles. Right. Right. So what is the benefits of predictive maintenance? So it accurately predict the failures, right? And it optimize the maintenance schedule. So you don't have to, spend money on the unnecessary the maintenance. So you don't have to sometimes, when you go to a garage, depending on the owner or depending on the technician, they will say a lot of things, right? So say you have to replace this, replace that, replace that, and blah blah blah, right? So if you know about the cars and the things very well, whether he's telling the correct thing or not. So you know what to do and what not to do. But the many people don't have that luxury, so they kind fall into the traps sometimes. But if you have these predictive maintenance systems and all the alarms and all the warnings and all the informations given to the user, user exactly know what's going on, and then what needs to be repaired and how much cost it will be, and so on. So nobody can fool the users. Okay. And it also increase the vehicle's longevity, right? Uh, so it increases the lifespan of the electrical vehicles. So if you do the regular maintenance, you know that it's obvious, right? So if the breakdown happens and then you repair it, like for an example, if you get an internal combustion engine type vehicle, if the gasket failure happen, then the engine, you have to repair the engine fully, right? And then the performance of the engine will be not good as the uh, original version, right? So rather than failure to happen and repair, the predictive maintenance will help you to do the maintenance in advance and prevent the failure. So your lifespan of the vehicle will increase, and also enhance the overall performance, reliability, as well as the comfortability of the vehicles and the user experience, right? So if you are I believe like many of you have driven a vehicles, and if you are driven a vehicle and if you own a vehicle, you know what you are looking for, right? So the comfortability, performance, and so those are the major things that you looking in a vehicle, right? And the reliability, right? So all those things can be increased by using this predictive maintenance, right? Okay. All right. Okay. Yeah. Yeah, it's very much similar. This, what is the importance in electrical vehicles? How important the predictive maintenance for electrical vehicles. So it will increase the reliability, and it will minimize the downtime time, and it optimize the performance of the vehicles, and the cost will be the reduce the maintenance cost and enhance the user satisfaction, right? So that's why the predictive maintenance is important in a electrical vehicle, right? Right. So, and as I said at the beginning, the predictive maintenance is depend on the data availability. So you need lots of data, right? So where to get these data, right? There are various types of sensors in electrical vehicles systems which supports the predictive maintenance. If you look at different parts, I'm just highlighting certain sensors associated with the certain parts, And there could be many other sensors, giving you lots of information about the electrical vehicle and its behavior, right? So it's, if you look at the, I don't know where to start with. Okay. Let's start with the battery, because you were talking about the, I believe you have learned a lot about the battery systems in the electrical vehicle. So if you look at the batteries, you have the current sensors, the temperature sensors, the humidity sensors, and the SOC and voltage sensors, right? So you need to monitor the battery carefully, and these sensors will give you a lot of data, so you can monitor the condition of the batteries, right? And then if you look at I will just highlight the certain parts. If you look at the electrical motors, right? So they have the position sensors and they have the temperature sensors, right? So okay, I will come to that. Something came to my mind. I was wondering whether to tell it now or later. Yeah, there were one research carried out by actually one of my friend, and he's in US, and then the research was actually carried out by one of the undergraduate in the Department of Electrical and Electronic Engineering, University of Peradeniya. And I am being a guy who teach the induction machines for that particular group, and he talked with me a lot and get a lot of support for this research. The research is that uh, how to determine the position sensor failures in the induction machines that used in the induction motors that used in the electrical vehicles, right? So you can see it's not just the failure of the motor that we were looking at, the people are looking at. It could even be the failure of the sensors, right? So if the sensor fails, then like for an example, if the position sensor fails, then the entire control system will go a little bit haywire. So you have to get it back to the stable situation, right? So how to detect this kind of the position sensor failures, and how to mitigate that, and how to how to continue with the proper control loop even with the position sensor failure. So that was the research. So it is directly connected to the electrical vehicle, right? So you can see that so that's a part of the predictive maintenance. So you have to determine the any failures in the sensor itself, right? So which eventually can cause many other failures, right? Uh, right. And then if you look at the certain other parts, like the inverters, you have to monitor the current, temperature, and the transmission system. You have to look at the positions and the speed and so on, right? So the various part of the electrical vehicles have various sensors integrated, right? And these sensors provides lots of data. And if you have a proper way of collecting the data and analyzing that data, you can do the predictive maintenance in much easier, right? Right. So what are the tools that we can use to do the predictive maintenance, right? So with the availability, or with the intention of collecting lots of data and analyzing that data in order to predict the possible failure. So that's the major task of the predictive maintenance. So in order to do that, first you need to collect the data from these kind of sensors that I have shown you, right? So the one way that you can do is by using the Internet of Things, right? So I believe you have some idea about what's the Internet of Things is, right? And if you don't, uh, so the Internet of Things is basically, it might have a slide that, yeah, right. So it's basically collecting the the networking the lots of I would say the embedded systems, right? So these sensors and everything, so they fall under these embedded systems. So you network all these sensors, right? By using some sort of embedded system, so by other means, in order to collect the data. So that is called the Internet of Things, right? So related to the electrical vehicles, but the Internet of Things is a very the broader topic, so you can apply it into the many situations. But talking about the electrical vehicles, right? So you have these embedded sensors and you network them to facilitate the seamless exchange of data between these sensors and the uh, uh, your monitoring system through the you can use the internet to facilitate the data transmission, right? That's why it is called the Internet of Things, right? So now once you have the data, uh, and also, sorry, in order to, before you go there, so in order to collect this data, you also need the condition-based monitoring equipment, right? Like for an example, the acoustic monitoring, infrared thermography kind of thing, and vibration analysis tools and things like that, which also gives you certain data that is required for the predictive maintenance, right? So once you have all this data, now you can start doing the magic, right? And there are a lot of tools available. So you can use the big data analysis in order to analyze the data, and then predict any the failures and things like that, right? So I will go into a little bit detail in upcoming slides about these different tools, right? And also you can use the machine learning models, right? So which are very much popular these days. People are talking about the artificial intelligence, machine learning, right? And neural networks and things like that. So where you can again play with the data in order to do some classifications and predictions and things like that, so which will eventually help you to predict certain possible failures. So that's another tool. So you have a big data analysis you can use to analyze this data and to maintain any to predict any failures. And also you can use the machine learning models to do a very similar thing, right? And also another the important domain or the another important tool that you have for this predictive maintenance is the digital twins. Okay? If you don't know what the digital twins is, the digital twin is a virtual representation of the physical assets. Like for an example, if you get a electrical vehicle, you have a virtual representation of that electrical vehicle in a somewhere in a cloud or somewhere in the internet, right? So people can do a lot of research on that, the virtual thing, rather than doing the research in the actual EV, right? Now, for an example, if you want to change the certain sensor output and see like what's going on, you can't do it in a actual vehicle. Probably it may be one thing, it may be very costly, and one thing, it may be not that safe, right? So rather than doing the research in the actual vehicle, so you people can do the research on the electrical the digital twins. They can test various algorithms and various things. So these digital twins represent the exact replica of this physical or the actual electrical vehicle by means of the data, right? By means of the real-time data. So all the real-time data collected from this actual electrical vehicle will be uploaded to the digital twin in the internet. So you get the exact behavior of the real EV in the virtual digital twin, right? So that's why it's called the digital twin, right? And it is digital and it's an exact replica of the real system, right? So you need all the information coming from these sensors and other systems of the EV, and you should upload them real time to the digital twin so people can see exactly what's going on and they can play with the digital twin without damaging the actual vehicle, and they can come up with the various algorithms and many more things, right? So that's why this the digital twin is very important, right? Especially in maybe in any scenario, but when you're talking about the predictive maintenance also, to develop the algorithms needed for predictive maintenance and even testing the algorithms for predictive maintenance, these digital twins can play a major role. Okay? Right. So let's look at the these things one by one, a little bit in more detail. So the Internet of Things. So you do the real time monitoring, right? And so you collect the data in the real time by using the Internet of Things, the various sensors network together, and you have to facilitate some sort of a data exchange, right? So these devices should communicate seamlessly, sharing the crucial data, right? And make sure that data is available at a central location so the people can access it, right? And also this will also be because of the availability of the lots of data through the Internet of Things. So actually, when you talk about the Internet of Things, the data collection is the one part, and the other part is the control, right? In EVs also, you can use the Internet of Things in order to control the electrical vehicles as well. But here actually I will focus more on the data collection part, right? Because I am talking about the predictive maintenance, right? So once you have the data, you can use this data for the remote diagnostic, right? Okay, so you can collect all the data relevant to EV's health, right? Maybe from a one EV and maybe from the fleet of EVs operating in a certain city or belonging to a certain EV manufacturer, right? So you collect the data, right? And you can do the remote diagnosis by looking at the data, right? And if EVs experience any abnormal vibrations in the motors, this IoT system, for an example, the IoT system detects and send this data to the remote diagnostic center. So the people can find out the solutions for this kind of behavior. Probably this in this way they can advance the technology. So in the upcoming versions of that particular EV brand, they can mitigate this kind of issues like these vibrations in the motors and things like that, right? So that's called the remote diagnostic. So that is also facilitated by the Internet of Things, right? And you can also do the predictive analytics, right? So this utilize the big data to forecast maintenance needs, reducing unexpected failures, And the IoT sensors in the EV's battery pack, it can continuously send data, right, about the charging patterns, for an example, right, and the state of charge and temperature, right. And then you can develop machine learning models to model the behavior of the battery systems, and to determine any abnormalities, and to see how the battery system will behave, right. And it can also, based on the information they collected, you can develop algorithm to predict the battery system behavior, and how likely the it to be reach the end of its life, and so on. So how soon you need to replace the battery systems, and so on, right. So those kind of things can also be done through the Internet of Things, right. And also, as I said, the other side is the control side, or the sending the data from the central location to the EV, right. So you can, by using that part in the IoT systems, you can do the over-the-air updates of the remote software or the firmware associated with the different parts of the electric vehicles, right? Like maybe in the control systems, maybe in the warning systems, or maybe displays or things like that. You can update the software remotely, and you can also do the calibration remotely by using the Internet of Things. So it works both the ways. You collect the data, as well as you can send the data from a remote location to the EV. Right? Okay, so that's the Internet of Things. And then the next tool, as I said, is the big data analysis. Okay. Uh, so in the big data analysis also, to be honest, I'm not much expert in the big data analysis side. Uh, so you collect the data, right? And then the data collection and integration, and also when you are collecting the big data, one of the major concern is like, what is the data you really need, and what is the data that you can filter out, and things like that. So that has to be also determined in this data collection and integration, right, part of the big data analysis. And then once you have the data, you can do the anomaly detection. So you can detect any abnormal behavior of the data by doing various pattern recognitions and various other types of analysis associated with the big data, right? And you can also do the trend analysis to see, like, for an example, the trend analysis of the EV batteries, right? In order to analyze any cell failures, or any degradation of the batteries over the time, right? Which will help you to do the maintenance or replacements of the batteries in advance, right? And with the big data analysis, you can also do the real-time analysis of data, right? So the data will be available much frequently, and it will be a continuously streaming data. So you can continuously analyze this streaming data, and so you can do the real-time monitoring of electrical motors, battery systems, and that will help you to immediately detect the issues like overheating, right? And if there's any signal failures, so you can detect them as well, right? So it will be happening the real time, right? So there is a real-time monitoring system. Uh, so this, the EV manufacturers, they can use these the options to real-time monitor the EV fleets in all over the world, right? And their behavior under different conditions, and so on. Okay. And the machine learning is very the more popular technique in the today's world. So you can use this to do various kind of things. Like for an example, so you can detect the anomaly. So that's the major thing in the predictive control, predictive maintenance. So you have to first detect the anomaly, right? So the machine learning algorithms such as k-mean clustering, autoencoders, and isolation forest, they can be used to detect anomalies in the sensor data, right? So there may be many other different algorithms. I'm just giving some examples. So and if you are interested, you can dig into more detail, right? So these algorithms can be used to detect any anomalies uh, in the electric vehicles, right? Based on the data you collected, right? And you can also do the predictive modeling for component failures, right? So algorithms such as the trees, random forests, the support vector machines, and neural networks, right? They can be trained on historical failure data, okay, to predict when a specific component is likely to fail, right? So they can kind sort of a trend analysis, right, based on the failure data in the history. You can train this algorithm. So once the new data comes, it can easily predict any specific component failure, or the likely to whether it's likely to fail or not, right? And also it can also suggest the specific repairs, okay? uh, and the failure classification is also very important in the predictive maintenance. So once you detect the anomaly, right, so you detect there's something going on and something is wrong. That's the anomaly detection. And once you detect the anomaly, you need to classify this, what kind of a failure is this, right? So this anomaly is related to, right? So you can do that by using the algorithms like random forest, support vector machines, and neural networks, right? So you can do the classification by using the machine learning models, okay? So you can classify into the many failure types, like the mechanical failures, electrical failures, or software malfunction, or you can even go into more details, and you can identify whether it's a battery failure or whether it's something else, and so on, right? I will show you some research that's happening in the world later, right? And then you can use the deep learning algorithms for very complex systems, right? So the deep learning algorithms such as convolutional neural networks and the recurrent neural networks. So these are applied to more complex systems, right? Where the standard algorithms may struggle to detect any patterns, right? So that's depend on the system. Like for an example, this okay, so what will happen to the control system when the three-phase induction machines position sensor failure? So these kind of complex things can be addressed by using the deep learning algorithms, right? And then you can do so once you identify the failures by using the failure classifications or deep learning for very complex systems, you can do the predictive maintenance scheduling, right? So this so the in here the what you are doing is you combine with the optimization algorithms. So the machine learning outputs, you combine them with the optimization algorithms to schedule maintenance activities at the most effective time. So once you identify the failure, so you need to identify what is the optimal time and to do the repair. So you can do that by using certain optimization algorithms, right? So for an example, the machine learning models predict failure times, as I said, and then the optimization algorithm schedule the maintenance for electrical vehicle fleets in a way that minimize the downtime and the cost. Like for an example, think about the electric transportation system, like the electric buses, right? So you have to schedule the maintenance in these buses such a way that it will minimize the unavailability, and it will minimize the cost, because if the bus is not running, there's a cost associated with that. You will lose certain income, right? So you have to optimize that as well. So with all this, they can use the optimization algorithms to schedule the maintenance at the right time. Okay, so that is the beauty of the predictive maintenance. So you can see it's not just detecting the failures; it's go even beyond. So how to do the maintenance, what maintenance you need, and what time you should do it, and how to optimally schedule it, so you will lost your downtime would be minimum, or your cost associated with that would be the minimum, right? So all those things can be facilitated. Okay, and also the fault diagnosis, right? uh, so not only the predicting when a failure will occur, but also in diagnosing the root cause of the issue can also be done by using this machine learning model. Right? So the things like pattern recognition and historical data analysis, and they can be used to identify the root cause of the issue as well. So sometimes uh, detecting the failure and the repairing the failure will get your vehicle back into good shape for a shorter period of time. But if you don't address the root cause properly, then the similar failure or the associated failures will come later on, right? So if you have run a vehicle, you should have this kind of experience, right? So in order to avoid that, this you can perform the fault diagnosis as well by using the machine learning model. So you can see the machine learning models will greatly help for the predictive maintenance. So it goes beyond just identifying the failures and just scheduling the maintenance, and it goes beyond that, and it can also identify the root causes of the failures, so which will eventually increases the what you call this the lifespan of the electrical vehicle, the compatibility and safety and everything. Okay, so yeah, so and the digital twins, right? Okay. So as I said in the earlier as well, so digital twin is the exact replica of the physical electrical vehicles, or the fleets of the electrical vehicles, depending on your requirement, right? And you can use the digital twins to simulate the vehicle behavior and component degradation, right? Based on the available data in the digital twin. And you can also use like what if scenarios and predictive simulation. So as I said earlier, so these things may not be easy to do in a real system when it is actually running. For an example, think about the electrical transportation system, buses or electrical trucks, right? So you can't experiment on those because they are running on a schedule, they are running on a cost, and they are running on certain targets and things like that. So you can't experiment with them, right? But you can experiment with the digital twins of these vehicles, right? Without affecting the actual day-to-day the behavior or the day-to-day the task of these actual vehicles, right? You can do kind of what if scenarios, like what if I do that, and then what if I change the, like for an example, what if I change the battery temperature for some reason, right? Maybe the environmental temperature goes high and the battery temperature goes very high for some reason. So what, how can I do that, right? What if that happens? So you can do it in the simulation level, and by using the actual data, right? And then you can do some the predictive simulation, so you can predict certain things by doing this what if scenario, right? So without damaging, like if you do what if scenario in a real vehicle, that might damage the vehicle system as well. So it is much safer to play with the digital twins than the real world thing, right? And you can do the remote diagnostic and the maintenance decision supports, right? The beauty of the digital twin is that the digital twin is accessible from anywhere in the world, so you can get the expertise from different parts of the world. Maybe one group from US, one group from Germany, and one group from China, maybe working on the same digital twins, right? Diagnosing the or trying to find the solution for a certain same problem, right? So you can get the expertise from different parts of the world, and collaboratively work on these digital twins, okay? And it's a continuously learning and model refinement. So you will learn about the electrical vehicle behaviors continuously by looking at these digital twins, and then these models will be refined continuously, because the data collected from the systems and the sensors of these electrical vehicles or the electrical vehicle fleets will update the digital twins. So it is the refining continuously, right? So you have uh, exact replica of the real world thing, okay? Right. So let's briefly look at the different types of research that's happening in the world. Due to the time limitation, I have just picked up I think two or three examples, and I will give you just the flavor. And there are many research happening in the world towards the predictive maintenance of the electrical vehicles. Okay. So the predictive maintenance is closely related to modeling a system's normal behavior and detect any divergence of the normal behavior, which is called the anomaly. So the anomaly detection is one of the major part in the predictive maintenance. So there are a lot of research happening on that area as well, right? So in the automotive safety standard ISO 26262, the anomaly is defined as a condition that deviates from expectations based, for example, on requirements, specifications, design documents, user documents, standards, or on experience. Right? So that is how the anomaly is defined in the automotive safety standards. Right? And the data sources for this anomaly detection could be various things like trouble codes, for example, from connected vehicles. Okay, so the vehicle may go to the repair shop, and it's so when you go there, the these visits details are collected, right? And if any repair is done, the repair history is also be collected uh, by using the Internet of Things or various other means, right? So those are the data sources for the research that are happening in the world, right? So saying so, we talked about the big data, machine learning, and then the digital twins. And according to our discussions, you might have noticed that all these things depends on lots of data, right? So the data is the one major thing that drives the predictive maintenance as well as the research related to the predictive maintenance. And saying so, the availability of the data is one of the hurdle in the electrical vehicle research as well. Right? So you have to find the data, the reliable data for your research. So there are various approach to detect the anomalies, right? So you can do the physical model, right? So you can model the normal behavior based on the underlying specification. Okay, uh, so that is the physical model of the system, right? And that then any abnormalities can be detected by looking at the behavior of the physical model. So in a normal situation the system should behave like this, and if you look at any anomalies you can easily identify them, right? uh, So, like softwares like you can use softwares like MATLAB to do the physical modeling. Like for an example, how to model the behavior of the induction machines, right? And the complete systems, including the drivetrain and so on. So there are the modeling components available in for an example, in the MATLAB Simulink. You have the various components to model the physical system, right? So you can do that and use them to detect any anomalies. Like for an example, this sensor failure that I was talking about, you can the student was actually simulating it in the MATLAB. Okay, and then you can use the machine learning algorithm, so you can do the supervised anomaly detection, right? So if you have the data which representative with the representative data with anomalies, right? So you have the data and you have the labels, so uh, labeling whether it's an anomaly or not, right? So in that case you can use the supervised anomaly detection, or you can use the supervised machine learning algorithms, right? uh, So you can do the two class or the multi-class classification. Okay, you can use the vector machines or the random forest or XGBoost and the deep learning models for that purpose, right? So for supervised anomaly detection, or basically the supervised learning in the machine learning. Okay. And yeah, the in the real world, it's not very easy to get the data with the anomalies already identified, right? So if you get the data, sometimes the number of data will be less, right? But you can get more data with some data labeled as with anomaly or not, and some data are not labeled. So if that is the case, you can use the semi-supervised the anomaly detection, right? Uh, so you can do the one class classification whether there is an anomaly or not, right? So you can use the support vector machines and one class deep learning methods for that purpose. Okay. And in the most of the cases, the data may not be labeled, so you can use the unsupervised anomaly detection So this is not an easy task. So those who are aware with the about the machine learning and related topic, you know that the unsupervised learning is not a very easy thing to do, right? But you can still do it by using the clustering techniques and the tree based methods or neural network based autoencoders, right? And there could be various other different algorithms that you can use. Okay? So and again, those who are familiar with the machine learning, they know that how the machine learning works. So you tried with the various algorithms, maybe belonging to depending on the nature of the available data, whether they are labeled or not, right? You can try various algorithms, and then you can couple these algorithms and go for hybrid approach, right? So you can also combine the data driven and the physical models together. So these are the data driven models, the machine learning algorithms, and then you can combine that with the physical models, and then you can build a more effective way of identifying the anomalies. Okay. So this is one of the research on fault detection and diagnosis of batteries. So this research is based on the big data analysis method and performed by the Shao and his group, right? And this publication is done in the year 2017, right? So what they have done is they have tried to identify any failures in the battery system, right? Uh, so this data was collected from the Beijing Electric Vehicle Monitoring and Service Center, okay? So which is the big data platform for electrical vehicles in China, right? Uh, so so this data on this battery system includes the total voltage, the current of the battery systems, and the state of charge state, and the cell voltages, the temperatures of the battery pack, and so on. And it also include the motor drive system data such as the voltage, current, speed, torque, temperature, okay? And also the vehicle system control system data, right? Like vehicle speed, gear position, accelerator pedal value, brake pedal values, and so on, right? So you can see that there are a lot of data involved in this research, right? So you just can't get just the battery data will not be enough to carry out the research in a more effective manner. So you need all the related components and their associated data as well, right? Okay. So they have then established the model. I'm not going to talk about the detail of the model due to the time limitation, right? And you can refer to the paper if you are interested in this. Okay? And they have detected the uh, yeah. Okay. So they have what you call, they have used the artificial neural network, okay, to detect the failures or detect the any issues in the battery cells, right? So you have this the battery system, right? So in there also you have different battery cells in here. So here you can see here you have the cell number and the fault efficiency, the probability that there could be the fault, right? So they have developed their own algorithms, and they have tested with the 3 sigma threshold value, and then they have use the unsupervised local outlier factor algorithm and a clustering based outlier detection algorithm, right? So you can see they were able to identify the possible failures of the battery cells, right? So here you have the cell number and then the fault frequency, right? The possibility of failure is in here. Right? So for an example, here you have the according to LOF algorithm, they have detected the cell number 40 has a 0.16 fault frequency, and according to the COF algorithm, the same will has detected as 0.14. So different algorithms gives different performance. Okay. The main idea is that now by using this algorithm, they can but with the data available, they can predict the possible failures of different cells of the battery pack. Right? So this is the analysis for a whole month. Right? So this is the date, and this is the number of cells, and then the fault frequency, the possibility of a fault can happen. Right? And then they have also done the seasonal analysis. So depending on the seasons, which cells have the ability to fail. So you can see that it is the similar set of cells that are showing these the failure probabilities or the possibilities. Okay. Right, so that was by using the big data analysis and the algorithms associated with that. Okay. And then this the Bittner and his group, they have done what they call the consensus self-organized models for fault detection. So here what they have done is they have actually collected the data from the vehicle fleets, such as the electrical buses, right? Electric buses. Sorry, oops. Okay. And so what they have done is they have collected the information and they have built up a knowledge over the time, right? By using the local signals that are collected from these electric vehicle groups, right? And then they call this their algorithm as Cosmo, right? This Cosmo was used to do the predictive maintenance of vehicle fleets. Okay. So in this vehicle fleet, the majority of the vehicles is assumed to be healthy, and deviation from the majority can be considered as the potential failure. So they are trying to identify the any anomalies, and the vehicles who have anomalies has identified to be the potentially faulty, right? And then then the fan and his group, they have used this the Cosmo algorithm to detect compressor failure in a fleet of a city bus, right? So you can see that these consensus self-organized models can be utilized to detect various different types of issues. So this fan and his group, they have used it to detect the compressor failures in a city bus, right? Okay. And then the Kalin and his group, they have proposed the IoT-based predictive maintenance for fleet management, right? So the going with the same line as the Cosmos. So they have proposed the IoT-based system to collect the data, and then based on the data they can do a they can do predictive maintenance for the vehicle fleets. Okay. So this is their proposed system. Okay. Okay. So they have three layers: the perception layer, the middle layer, and the application layer. Right. So the perception layer is corresponding to the vehicle fleets, the vehicle node, right? So in each vehicle, you have the CAN network, which collect the various information about the sensor about the vehicle from its systems and the corresponding sensors. And there is a local database. They store the data in there, and they transmit the data to the middle layer by using the LTE or Wi-Fi, right? So you have such many number of vehicle nodes like that, because they were talking about the vehicle fleet. And then in the middle layer you have various distributed databases, right, connected through the wide area network, right? They can collect the data from many different locations, within a city or within a country, right? And then through this wide area network, all these distributed databases are connected, and it is connected to the centralized database, right? So at the application layer. So here you have all the information about these vehicle fleets, and then you have the users and managers and administrators connected to this, and do uh, uh, the various analyses and identify any predictive maintenance and so, right? So they propose this hierarchical structure to collect the data and then do the various other the run the predictive maintenance algorithms on this data, right? So again, due to the time limitations, I'm not going to go into details of this uh, the research. Okay. So these are some example research that I wanted to highlight. And there are many other the research are happening. So if you are interested in a certain area, you can look for any ongoing research and study about it. Okay. Uh, okay. And if you look at the market trend, so in the predictive maintenance, okay, you can see that so automotive sector is increasingly adapting the predictive maintenance for electric vehicles in order to enhance the reliability and the performance, so that the market for the predictive maintenance is the rapidly increasing. So in order to do the predictive maintenance, as you know, you need these tools like IoT and big data, right? So the integration of IoT device is also increasing, right? And the big data analysis market is also increasing related to the electric vehicles, right? And so the focus is basically on the cost reduction, right? So there is a growing emphasis on reducing the operational cost through efficient maintenance practices, right? So which will benefits overall businesses performance, right? That's the main idea. Okay. And also the enhancing the operational efficiency, right? So you know that by now the predictive maintenance not only decreases the downtime, but also enhance the operational efficiency across the electric vehicle life cycle, right? So depending on how you do how you schedule the maintenance and so on, and you can enhance the operational efficiency. Okay. So this is not just applicable to individual electric cars, but it applicable to many other things like especially as the research that I was talking about, they were mainly focusing on the vehicle fleets, right? Such as the city buses, or it can go even beyond, like such as the electric trucks, right? So transporting the various stuff all around the places in the country. So how the company owning these trucks can use the predictive maintenance in order to reduce the cost associated with the maintenance, as well as to enhance the efficiency of the system. So you minimize the downtime of the certain vehicle, and optimally schedule the maintenance, so that you increases the overall efficiency. So all those factors needs to be looked at. Okay. So as I said, the challenges of the predictive maintenance is, one is the data, right? So you need the very large sets of data, right? So that's one of the main challenge. Okay. And then the data quality, right? So how good the data is, right? Uh, so it doesn't matter you have the millions of data if they are not in a good quality. If you have lots of missing data, then you can't run the algorithm as expected. So their performance will be less. So you may have to get rid of half of the data, right? So the data quality is also important, right? and any unforeseen faults, so with those kind of things, it's very hard to do the predictive maintenance, right? So you have to have a certain history of these faults, and if a certain fault has a good history, then it is easy to develop algorithms to detect them and so on. But if there are any unforeseen faults, it's not easy to detect them, right? So those kind of the limitations and challenges are there in the predictive maintenance. Right? Yeah, so we are almost running out of the time. So so this is again will be the similar thing that you have seen so far. I will just brief them about the applications of the predictive maintenance. So you have seen that the enhancing the battery performance is one of the application, right? So you can analyze the optimal usage of the battery, and the predictive failure forecasting, increase the battery lifespan, and enhance the efficiency matrices of the battery. So this is one big area of research, the electric battery, because in the electric vehicle, the battery is one of the major components, and the performance of the vehicles depend on the battery. How far, or what's the maximum kilometers that you can go, right? And how often you need to do the maintenance of the battery and everything, right? And also I don't know whether you have seen them. You might have actually heard about them throughout the workshop. So there are different charging techniques available. You have the slow charging, fast charging, and so on, right? So how the battery system will behave under these charging condition is also very important. So you have to collect all the data in order to predict any the failures due to this a different type of the charging doing in the battery. Okay. And also there is a new and more faster way of you know how can I say that if you want to go from certain location to other, you want to go it with the minimum delay, right? So the one way of facilitating that is rather than charging your electric vehicle in between, there is a technology called the battery swapping, right? So probably you might have heard about that, right? So the electric vehicles goes into a certain booth, and the batteries underneath the electrical vehicle, so they take that battery out and then put the new battery and so on, and then that battery will charge by, and it will be placed in somebody else's vehicle, right? So you can see that your battery is now no longer yours. So if you keep your battery nicely and do all the maintenance and the things, there will be at some points the somebody else will own that battery, and somebody's battery which is not maintained very well, maybe come into your car, right? So so in order to avoid this kind of the bad batteries getting into your cars and so on, so this predictive maintenance is also very very important, right? So that's another scenario that can actually happen. And another applications in these the predictive maintenance can use is the advanced driver assistance systems, right? So you can, as we discussed, you can collect the real-time data related to this driver assistance system, and you can do the predictive analysis, and you can enhance the safety features by using this analysis, right? And you can improve the driver experience, and which will in turn lead to the very very sustainable system. Okay. Okay. Uh, and so this kind of the predictive maintenance is very important in the connected EVs, right? Especially in the EV fleets that we discussed, like the city buses, and then the what we call it, the logistic systems which use the electric transportation, like electric trucks and so on, right? So they can you can use the IoT and big data analysis and the machine learning to continuous performance monitoring, right? And okay. And any predictive maintenance in these electrical fleets. So you have seen the many research are going in this area, and also there are a lot of the practical the applications going in this area. Okay. Okay. So yeah, since the time is up, I think it's 1.5 hours that we were targeting at. So you can see that the autonomous public transportation is becoming more and more popular, right? So the development of autonomous vehicles, or going with the electrical vehicles, the next stage would be the autonomous vehicles. So there are many countries, like if you go to China, actually you can order this the autonomous taxis, right? And you can get in and go wherever you want to go, right? And then the okay. And then the other focus is the efficient transportation system, right? So you can use the big data analysis and to monitor and investigate where are these your electric vehicle fleets are, and how what are they doing, how they are behaving, are there any possibility of failures, right? If so, you can route them back to the service center, and then do the repairs and so on, or you can optimally design when to transport them into the service center and do the repair, right? And you can determine how critical the failure is and so on, right? So you can manage your the transportation network very efficiently, right? Uh, okay.
And you know that you might learn about these things during your workshop. So it's eco-friendly, the solution, the electric vehicles, electric trains, electric buses, and so on. So which minimize the environment pollutions and so, right? And so the predictive maintenance plays a very critical role in the autonomous the public transport. As I said, so you need to monitor the behavior, because this is directly related to the safety of the passengers, right? Thousands and millions of people we are talking about. So you can use the predictive maintenance to predict the possible failures, and to optimally schedule the maintenance such a way that the minimum disturbance will happen to the public, right? Or the public who use these transportation systems, and the safety of these public would be at its best, right? So that's the role of the predictive maintenance in the autonomous public transport. Okay. Okay. So the predictive maintenance, as I said, is especially in the EV case, this is relatively young, right? And so there are lot to be done in the future, right? So the standardization being one of them. So there should be many standards that should be developed for the predictive maintenance, right? And then the IoT needs to be there needs to be a lot of advancements that needs to be happens in the Internet of Things technology, especially when it comes to the electric vehicles, which are actually, the IoT is many popular for the applications like the stationary kind of applications like home automations and things like that. But when it comes to the EVs, now we are talking about new environment. Everything is mobile, moving around the cities and things like that. So passing through lots of obstacles, going through the tunnels and things like that. So there need to be advancements in the IoT architecture to facilitate these kind of things as well, right? And the integration of the big data analytics, right? So as you have seen, it will facilitate the smarter decision making, right? And the prediction. And then the big data analytic techniques has to be also advanced. You have to detect what data to use and what data to filter out and those kind of things, right? The data mining part is also very important. And the and the maintenance service models, these are this maintenance as a service model will provide a flexible and cost-effective maintenance solution for electric vehicle owners, right? So now things are going beyond, if you look at the telecommunication industry in the good old days, the telecommunication service industry is basically a industry that providing the connections, that means connectivity between one person to other. So they were focusing on the telephone call and the quality of the voice and things like that. And then if you look at nowadays, they are more focusing towards the service orientation. There are a lot of services they were looking at, right? Maybe telemedicine and things like that, right? So it's more service oriented model. So the same thing will happen in the predictive maintenance as well. So the maintenance as a service model will be the future of the predictive maintenance. Okay, so to conclude the discussions, we have talked about the lot of things associated with the predictive maintenance. Okay, So my whole idea was to give you the bits and pieces of the associated with this predictive maintenance. Actually, I was not trying to go into a depth of any of these, right? But now you know the major components associated with the predictive maintenance, and then some important aspects and the important algorithms and important tools associated with the predictive maintenance. So if you now if you're interested, you can dig into these things in details, and if you are planning on doing some research, or if you are planning on implementing certain tools, now you know where to step, or where to pick up, right? So we have discussed about the Internet of Things, and how the big data analysis, and the what you call it the digital twins and so on. And we talked about how the predictive maintenance can be used to enhance the reliability and the performance, right? And how it can be used to reduce the cost, and increases the efficiency of the electric vehicle fleets, right? And then we saw that the requirements of the continuous technological advancement that is needed to improve the quality of the predictive maintenance, and eventually go into the targets like the maintenance as a service. Okay, right. So that's all I wanted to talk about. I hope that you have get something important, and collect some knowledge that you can step into this domain if you're really interested in, or at least that this kind of the things exist. Okay, right. Okay, thank you very much, and thank you for listening. So if you have any questions, we can discuss.
Thank you, Dr. Sudheera, for that informative session. Your insights have truly added depth to our participants' understanding of predictive maintenance using IoT and big data analytics for EVs. I believe the foundation you have laid today will surely help our participants in their academic or professional journey. As we move forward, we'd like to open the floor for a Q&A session. We invite you to raise any questions or doubts you may have about the content that was discussed today. You may raise your hand and I will call out your name. Then you may unmute and direct your questions about the keynote speech to our speaker, or you may use the Zoom chat to ask your questions and I will read it out to our speaker. I encourage all the participants to make the maximum out of this opportunity and ask questions and clarify your doubts. To ensure that we have enough time to address as many questions as possible, we kindly ask you to keep your questions direct and to the point. This is your chance to ask any questions you have got. While we encourage everyone to take this opportunity to engage and seek clarification on any topics discussed, we understand that our participants may require more time to gather their thoughts. But time is of value, so we will head on with the program. However, if you have any problems do arise, please reach out to the Y2N Pro team and we will do our best to get them answered. Moving on, we would like to take a moment to express our gratitude to our esteemed speaker, Dr. Sudheera Navaratne, for accepting our invitation and sharing his valuable knowledge and expertise with us. Please accept our token of appreciation. Your presence here has set a high standard for the caliber of learning we can expect from this workshop series. Thank you once again, sir. Before proceeding, let's take a group photo to remember this valuable time we spent together learning today. I kindly request the audience and the OC members to switch on your cameras to take a group photo. Please make sure to use the virtual background we have sent you in the meeting invitation. Come on, guys, let's switch on your cameras. Let's wait a few seconds. I encourage everyone to turn on your cameras to take the group photo. Okay, I think we are good to go. All right, everyone, get ready. On the count of three, I'll give you a cue to smile and pose. 1, 2, 3, say cheese. Let's make sure we captured a good shot. Are we good to go, Viraj?
Yes, we are good to go. Thank you.
Thank you all. Also, please note that the quiz will be conducted on the 5th of October at the end of the workshop series. We have shared a feedback form in the Zoom chat now. Also, you can scan the QR code on the screen to access the feedback form. We kindly request you to take a few minutes to fill it out. Your feedback is extremely important to us as it helps us to continuously improve and provide you with better experience in the future. This will also be considered for your attendance. As we wrap up this session, we'd like to remind you that the final online session of the Battery Technology and Charging Infrastructure for Electric Vehicles workshop series will be held on the 22nd of September from 6 p.m. onwards, where Professor Atif Iqbal from Qatar University, fellow of IEEE, will take us through design and control of residential EV chargers. Before we officially close, it is with great sadness that we announce the sudden passing of Mr. Sadeepa Sepala. He was an invaluable contributor to our previous session on ham radio communication and an enthusiastic participant in our EV workshop series. His passion and dedication touched everyone who worked with him, and his absence will be deeply felt. Our heartfelt condolences go out to his family and loved ones during this difficult time. As we near the end of the session, we sincerely hope that you found the workshop informative, and that you leave with new insights and ideas. And with that, we conclude today's workshop. Thank you once again and have a good night.